In this lecture, we discuss about reduction formula, in which today we will discuss the history of reduction formula, definition of reduction formula, and we take the examples of reduction formula, and finally we see the different applications of the reduction formulas. Reduction formula history. The concept of reduction formulas dates back to the evaluation of calculus in the 17th and 18th centuries, primarily developed by mathematicians like Isaac Newton, then G. W. Leibniz, and the Bernoulli family. The reduction formula was introduced as a tool to simplify the evaluation of complex integrals by breaking them into smaller or more manageable pieces. These formulas have since become a cornerstone in mathematical analysis and are widely used in advanced mathematics and applied fields. So these are the history of the reduction formula. Let us take its definition. A reduction formula is a recursive relationship that expresses an integral involving a parameter often denoted as n in terms of another integral of the same type with a lower parameter. So reduction formula is a recursive relationship between the higher order of n and then related to the lower value of n. These techniques helps reduce the complexity of the original integral, making it easier to evaluate, especially for the definite integrals or when solving iteratively. General form of the reduction formula. It is written by In is equal to f of n into In minus 1 plus Gn, where In is the integral to be evaluated, f of n and g of n are functions of n, and In minus 1 is the reduced form of the integral. So here In is reduced to In minus 1, and now In minus 1 can be reduced into the In minus 2, In minus 2 can be reduced into In minus 3, and at the last we get what is the value of either I1 or I0. And then we are easily find out what is the value of I0 or I1. So this is called the reduction formula, and this is the general form of the reduction formula. Next, what is the examples of reduction formulas? Let us take the reduction formula of integration of sine to the power nx dx. So integration of sine to the power nx dx, which is equal to minus sine to the power n minus 1x into cos x divided by n plus n minus 1 upon n into sine to the power n minus 2x dx. This can be written as In, this is what it is In, which is equal to minus sine to the power n minus 1x into cos x upon n and plus n minus 1 upon n, and this is In minus 2. So now in this example, In is reduced to In minus 2. If we again simplify it, then In minus 2 will be reduced to In minus 4, and then In minus 4 should be reduced into In minus 6, In minus 8, In minus 10, and so on. So at the last, what we will see, either the last part will be either I1 or it should be I0. So suppose it is I1, then we have to put the value of n is equal to 1, then we are able to get what is the integration of sine x. And suppose it is 0, then sine to the power 0 is 1. So we are also get what is the integration of 1 with respect to x. So this is what it is, the first example of reduction formula in trigonometric nth derivative of sine in x. Reduction formula for factorial like integrals. If we take, if in is equal to integration of sine to the power nx dx under the limit 0 to pi by 2, then it can be written as in is equal to n minus 1 upon n into in minus 2. So again here, in can be reduced into the form of in minus 2. Third example is factorial n plus 1. Factorial n plus 1 is equal to n into n factorial. So here n plus 1 factorial is reduced into n factorial. Similarly, n factorial can be reduced into n into n minus 1 into n minus 1 factorial, n minus 1 factorial, and so on. Similarly, gamma function, if gamma of n equal to integration under the limit 0 to infinity of e to the power minus x, x to the power n minus 1 dx, then gamma of n plus 1 is equal to n gamma n. So these are some basic examples of the reduction formula. We study all these formulas in the coming lecture. Reduction formula, let us take its applications. First, in mathematics, simplifies complex integrals, making them easier to evaluate. Essential in deriving properties of spatial functions like beta and gamma functions. So these are very important applications in mathematics of the reduction formula. Let us take what is the application of reduction formula in physics. So it is used in solving wave equations in quantum mechanics, and it also evaluates integrals in electromagnetic theory such as field distribution. Now, the third application is in engineering. It applied in structure engineering, in civil engineering, to compute stresses and deformation integrals, used in fluid mechanics for solving flow equations and volume calculations. So these are two applications in engineering. Fourth applications of reduction formula is in computer science. It optimizes algorithms in a numerical integration and symbolic computation. Also, integral in machine learning for calculating complex cost functions. So these are two basic or mainly applications in computer science. The fifth one is in economics and finance. Reduction formula simplifies modeling in risk analysis and option pricing using probability distributions. Similarly, applied reduction formula is applied in computing movements in eco econometric models. Now, the sixth application in biology and medicine calculates statistical parameter in population genetics, and it is also useful in pharma pharmacokinetics for modeling drug absorption and elimination. Seventh is in chemistry. It helps in quantum chemistry to solve integrals for molecular orbits. Also, it is used in spectroscopy to calculate absorption and emission spectra. The eighth application is in environmental science. It applied in climate modeling to solve equations for heat transfer and radiations. Also, it evaluates pollutant dispersion using diffusion integrals. Now, it is also useful in astronomy because it solves integrals related to celestial mechanics such as orbital paths, and it also applied in calculating the luminosity of stars and other astrophysical quantities. And at the last, signal processing. It is used in deriving coefficients for Fourier series and transforms, and also it is essential for analyzing signals in image processing and audio comparison. So these are some applications of reduction formula. So this all for these lectures. Thank you.